Have you ever wondered what would happen if the sun simply vanished? Not exploded, not dimmed, but just disappeared. Gone. Erased from existence in an instant. How long would we have? What would we feel first? And how would the end actually come? Tonight, as you drift towards sleep, we're going to walk through this impossible scenario. Minute by minute, hour by hour, we'll trace what would happen to Earth if the sun suddenly ceased to exist. We'll feel the darkness fall, watch the sky transform, and follow our planet as it tumbles into the cosmic void. This isn't a story of sudden destruction. It's something slower, stranger, more haunting. Because even without the sun, Earth wouldn't die immediately. For a while, perhaps longer than you'd think, life would continue. People would wake up, go about their routines, completely unaware that their world was already ending. Before we begin, if you're kind enough, a gentle like or a quiet tap on subscribe would mean the world to me. It's a small gesture, but it keeps these quiet explorations alive and reminds me that these cosmic lullabies still find their way to gentle hearts like yours. Now, let's imagine the impossible. Let's watch as our sun disappears and see what happens next. Minute 0, the sun vanishes. Let's say it happens at noon, Greenwich Mean Time. One moment the sun is there, 93 million miles away, burning at 27 million degrees Fahrenheit in its core, fusing 600 million tons of hydrogen into helium every second. The next moment, it's gone. But here's the strange thing. Nobody knows. Not yet. According to Einstein's theory of relativity, nothing can travel faster than light. Not information, not energy, not even gravity. The sun's light takes 8 minutes and 20 seconds to reach Earth. So for those first 8 minutes and 20 seconds, nothing changes. The sky remains bright. Birds continue singing. The temperature stays warm. People go about their day, checking their phones, eating lunch, working at their desks. The sun's gravitational pull still holds Earth in its orbit. Everything feels completely normal. NASA's calculations confirm this cosmic speed limit. When the sun disappears, its light is already traveling toward us. Photons that left the surface minutes ago. Those photons don't know their source is gone. They continue their journey, crossing the void, carrying the last warmth Earth will ever receive from its star. The same applies to gravity. According to general relativity, gravity moves at the speed of light. When a massive object disappears, the change in its gravitational field propagates outward as gravitational waves, traveling at exactly 186,000 miles per second. So for 8 minutes and 20 seconds, Earth continues orbiting a sun that no longer exists. The planet follows the curvature of space-time that's still there, like a marble rolling in a bowl that hasn't yet realized the bowl is gone. This delay is one of the strangest aspects of our scenario. The universe doesn't update instantly. Information takes time to travel. Even something as catastrophic as the sun's disappearance needs 8 minutes and 20 seconds to make itself known. During these minutes, life on Earth is living on borrowed time. The last light, the last warmth, the last gravitational pull, all of it is still arriving, still functioning, still maintaining the illusion that everything is fine. Take a slow breath. Imagine those 8 minutes. The calm before everything changes. The last moments of normalcy before the darkness falls. Minute 8:20. The darkness falls. It happens all at once. The sun simply blinks out. No fade, no dimming, just instant darkness. As if someone turned off a light switch. The sky goes black. Not gradually, not slowly, but in a heartbeat. Anyone looking up would see the sun vanish, replaced by a dark circle where it used to be, surrounded by stars suddenly visible in the daytime sky. According to NASA's studies of eclipses, the temperature drop would be immediate but not catastrophic. During a total solar eclipse, Temperatures can fall by 10-15 degrees Fahrenheit within minutes. But that's temporary. This would be permanent. The disappearance would be visible worldwide, not just on the day side. On the night side, people would notice the moon vanishing. Without sunlight to reflect, the moon would become invisible, a dark silhouette against the stars. Only its gravitational effects would remain, still pulling at Earth's oceans, still causing tides. Within seconds, confusion would spread. People would look up, see darkness, and think there's been an eclipse. But eclipses are predicted. This wouldn't make sense. Social media would explode with posts, photos, videos, everyone asking the same question: what happened to the sun? But even in that first minute of darkness, the temperature wouldn't drop dramatically. Earth's atmosphere holds heat. The oceans, the ground, the buildings, everything that's been warmed by sunlight for billions of years wouldn't cool instantly. The European Space Agency's climate models show that Earth's average temperature would drop about 1 degree Celsius per week without sunlight. That first minute would feel perhaps a degree or two cooler, noticeable, but not deadly. What would be deadly is the panic. Without communication from scientists, without understanding what happened, people would rush to understand, to find answers, to prepare for their not sure what. Governments would mobilize. Emergency broadcasts would begin. But in that first minute, nobody would know what to say. The sun is gone. That's not supposed to be possible. There's no protocol for it, no emergency plan, no instructions. At the same moment darkness falls, something else happens. Earth stops orbiting. Without the sun's gravity, there's nothing holding the planet in its circular path. According to Newton's first law of motion, an object in motion stays in motion unless acted upon by a force. The force keeping Earth in orbit is the sun's gravity. Remove it, and Earth continues in whatever direction it was moving at that instant. It doesn't stop. It doesn't fall. It just keeps going in a straight line, shooting off into interstellar space at 67,000 miles per hour. NASA's trajectory calculations show that Earth would sail away from where the sun used to be, carrying the moon with it. The moon's orbit around Earth would remain stable, because that's governed by Earth's gravity, not the sun's. The moon would continue circling our planet, now a dark companion on a journey into the void. Within minutes, the other planets would do the same. Mercury and Venus would shoot off in their own directions. Mars, Jupiter, Saturn, all of them would become rogue planets, wandering the galaxy independently, no longer bound to a star. The solar system, built over 4.6 billion years from a collapsing cloud of dust and gas, would disintegrate in less than a day. Each planet would become its own isolated world, drifting through the darkness, carrying whatever life or structure it had into an uncertain future. Take a slow breath. The darkness has fallen. The orbit is broken, and Earth is now tumbling through space, untethered, heading nowhere in particular, carrying 8 billion people who are just beginning to realize that everything has changed. Hour 1. The cold begins. An hour after the sun disappears, the reality starts to settle in. The sky is black. The stars are out, bright and clear, even at what used to be midday. The temperature has dropped noticeably. People have gathered indoors, turning on heaters, lighting fires, trying to understand what's happening. According to climate scientists, Earth's surface temperature would drop from an average of 59 degrees C to around 36 degrees within the first week. But the cooling isn't linear. It's faster at first, then slows as the planet reaches equilibrium with the heat stored in its oceans and core. In that first hour, the temperature might drop 5 to 10 degrees, enough to feel cold but not dangerous. People would bundle up, put on coats, gather blankets. In warmer climates, it would feel like a sudden winter. In colder regions, it would feel like the beginning of something much worse. but the psychological impact would be far greater than the physical. The sun is gone. The sky is dark. The world feels fundamentally wrong. Even though people are safe for now, the knowledge that this is permanent, that the sun isn't coming back, would create a sense of dread unlike anything in human history. Scientists would be working frantically to understand what happened. Telescopes would be pointed at where the sun used to be, looking for any remnant, any clue. But they would find nothing, just empty space where a star once burned. The European Space Agency's satellites would show Earth drifting away from the inner solar system, moving at 67,000 miles per hour in the direction it was orbiting when the sun vanished. Within an hour, Earth would be about 67,000 miles from where it started. Still close by cosmic standards, but already untethered, already lost. At the same time, strange things would start happening to Earth's atmosphere. Without sunlight, photosynthesis stops immediately. Plants can't produce oxygen, but that's not an immediate problem. Earth's atmosphere contains enough oxygen to sustain life for thousands of years. What does change immediately is the upper atmosphere. NASA's atmospheric studies show that the thermosphere, the layer of atmosphere above 50 miles, is heated by solar radiation. Without the sun, it would begin cooling and contracting within hours. This would affect satellites. The International Space Station orbits in the thermosphere. As that layer contracts, the ISS would experience less atmospheric drag. It would maintain its orbit longer, possibly for years. But without ground support, without supply missions, the astronauts aboard would face their own crisis. Back on the surface, emergency services would be overwhelmed. Not with injuries or casualties yet, but with fear. People calling 911, asking what to do, where to go, whether they're safe. The answer would be uncertain. Scientists would know that Earth's stored heat would keep the surface habitable for days, maybe weeks. But what then? Governments would begin implementing emergency plans, rationing power, distributing food, mobilizing resources. But plans made for hurricanes or earthquakes don't apply here. This isn't a temporary disaster. This is permanent. In that first hour, the realization would spread. Humanity is on its own. No sun means no new energy input. Everything we have, food, warmth, oxygen, is finite. The clock is ticking. Take a slow breath. 1 hour has passed. The world is darker, colder, more uncertain. And this is just the beginning. Hour 12, the long night. 12 hours after the sun disappears, Earth has traveled 800,000 miles into interstellar space. The planet is now farther from where the sun used to be than the moon is from Earth. And it keeps going, silent, dark, carrying its cargo of life into the void. The temperature has dropped to around 20 degrees in most places. Cold, but still survivable, with proper shelter and heating. People have retreated indoors. Cities are running on emergency power. Street lights are on. Buildings are heated. For now, civilization is still functioning, but the darkness is absolute. Without the sun, without the moon reflecting sunlight, the night sky is the only light source. Stars shine brilliantly, unobstructed by light pollution or daylight. The Milky Way stretches across the sky in stunning detail, a band of light so bright it casts faint shadows. According to astronomers, this would be the clearest view of the cosmos humanity has ever had. With no sunlight to wash out the sky, even faint stars and distant galaxies would be visible to the naked eye. The night sky would become a dome of infinite lights, beautiful and terrible. But beauty doesn't provide warmth. The temperature continues dropping. NASA's climate models show that within a week, Earth's surface would freeze. Water would turn to ice. The oceans, which hold vast amounts of heat, would keep the planet relatively warm for months, but the land would become inhospitable. At this 12-hour mark, governments would be making critical decisions. Where do people go? How do we conserve energy? How long can we survive? The answer depends on preparation. Countries with nuclear power, geothermal energy, or large stores of fuel would fare better. Iceland, with its geothermal resources, could maintain heat and power for years. Nations reliant on solar power would be in immediate crisis. But even with power, there's the food problem. Without sunlight, crops die. Within days, every plant on Earth would begin to wither. Forests, farms, gardens, all of it would freeze and decay. The entire food chain depends on photosynthesis, and photosynthesis requires light. According to agricultural scientists, humanity has enough stored food to last months, maybe a year if rationed carefully. But after that, we'd need alternative sources. Hydroponic farms powered by artificial light could work, but they'd require enormous amounts of energy. The oceans would fare slightly better. Deep-sea ecosystems near hydrothermal vents don't rely on sunlight. They derive energy from chemicals in the water. Those ecosystems would continue, oblivious to the sun's disappearance. Strange, alien-looking creatures living in perpetual darkness would outlast most surface life. At this point, 12 hours in, the psychological toll would be immense. The darkness, the cold, the uncertainty would weigh heavily. Some people would cling to hope, believing this is temporary, that the sun will return. Others would despair, seeing no path forward. But there would also be resilience. Humanity has survived ice ages, plagues, wars. We adapt. In those first 12 hours, plans would be forming: underground shelters, geothermal cities, survival strategies for a sunless world. Take a slow breath. Half a day has passed. The world is darker, colder, stranger, but life continues. For now. Day 1. A frozen world. 24 hours after the sun vanishes, Earth has traveled 1.6 million miles into space. The planet is now far from the inner solar system, drifting through a region that was once empty, heading toward the outer darkness between stars. The temperature on the surface has dropped to around 0 degrees. Water is freezing. Lakes and rivers are turning to ice. Even in tropical regions, frost is forming. The cold is no longer just uncomfortable, it's dangerous. According to the European Space Agency's climate projections, within a week, the average global temperature would plummet to 100 degrees. Within a year, it would stabilize around 400 degrees, close to the temperature of space itself. Earth would become an ice world, frozen and dark, inhospitable to almost all life. But in that first day, humanity is still fighting. Power grids are strained but functional. Heaters run constantly. People huddle in insulated buildings, burning fuel, using generators, doing whatever it takes to stay warm. The sky remains pitch black except for stars. No sunrise, no sunset, just perpetual night. The psychological impact of this is profound. Humans evolved with a 24-hour day-night cycle. Without it, sleep patterns collapse. Depression rates soar. The darkness itself becomes oppressive. NASA's studies of astronauts in extended darkness show that the human body struggles without natural light cycles. Circadian rhythms break down. Mood disorders increase. Even with artificial light, the absence of the sun creates a deep, unsettling void. At the same time, Earth's atmosphere begins to change. Without solar heating, the air starts to cool and contract. Weather patterns, which depend on temperature differences, begin to collapse. Winds slow. Storms dissipate. The atmosphere becomes eerily still. Within days, the air would start to freeze. First, water vapor condenses and falls as snow. Then, at around 150 degrees, Carbon dioxide begins to freeze out of the atmosphere, falling as dry ice. Eventually, even nitrogen and oxygen would liquefy and freeze, covering the ground in layers of frozen air. But this process takes weeks or months. In that first day, the air is still breathable. Cold, but breathable. People can still go outside briefly with proper clothing, but every hour it gets harder. By the end of day 1, humanity faces a stark reality. The stored heat in Earth's oceans will keep the planet relatively warm for months, but eventually, that heat will radiate into space. The oceans will freeze, the atmosphere will collapse, and Earth will become a lifeless ice ball, drifting through the galaxy for eternity, unless we act. In that first day, scientists and engineers would be working on solutions. Underground cities powered by geothermal energy, nuclear reactors to provide heat and light, hydroponic farms to grow food, ways to survive in a sunless world. It's possible. Difficult, but possible. A small fraction of humanity could survive for generations in artificial environments, deep underground, drawing energy from Earth's core. We wouldn't thrive, but we wouldn't die immediately either. Take a slow breath. One day has passed. The world is frozen, dark and drifting, but life, stubborn and resilient, continues to hold on. Week 1, the Great Freeze. A week after the sun disappears, Earth has traveled 11 million miles. The planet is now well beyond the orbit of Mars, heading outward into the asteroid belt and beyond. The surface temperature has dropped to 100 degrees Celsius. The world is frozen solid. Every body of water, from the smallest puddle to the largest ocean, is covered in ice. The ice grows thicker each day, expanding downward as the cold penetrates deeper. According to oceanographers, it would take years for the oceans to freeze completely. They hold too much heat, but the surface would solidify within weeks. This ice layer has a strange effect. It insulates the water below, trapping heat and slowing the freezing process. Beneath miles of ice, the deep ocean would remain liquid for decades, possibly centuries. Life in those depths would continue, unaware of the frozen wasteland above. On the surface, almost all life is dead. Plants have frozen and died. Animals without shelter have succumbed to the cold. Only humans with their technology and a few hardy microorganisms remain. But humanity's grip is tenuous. Power grids are failing. Fuel supplies are dwindling. People have gathered in the warmest, most secure locations. Underground bunkers, geothermal facilities, nuclear power plants, anywhere that can generate heat without sunlight. And NASA estimates that with proper preparation, a small population could survive for years. But we're talking thousands of people, not billions. The vast majority of humanity would perish within weeks, victims of cold, starvation, or collapse of social infrastructure. The atmosphere is changing rapidly. Water vapor has frozen out completely, falling as snow that never melts. The air is dry, cold, and thin. Carbon dioxide is beginning to freeze, creating dry ice storms that coat everything in white. At this point, anyone venturing outside would face instant frostbite. Breathing the air would freeze lung tissue. Survival outdoors is measured in minutes, not hours. The world has become as inhospitable as Mars, a frozen desert where even the air is deadly. And yet, deep underground, in geothermal caverns heated by Earth's core, life could persist. The heat from radioactive decay in Earth's interior would continue for billions of years. That heat could power small communities, provide warmth, run hydroponic farms. Take a slow breath. 1 week has passed. The world is unrecognizable. But deep below the frozen surface, in pockets of warmth powered by Earth's dying heat, humanity's remnants survive. Month 1, a dead planet. Drifting, 1 month after the sun disappears, Earth has traveled 48 million miles into space. The planet is now drifting through the outer solar system, passing through regions where asteroids orbit, heading toward the darkness beyond. The surface temperature has stabilized around 200 degrees. The oceans are frozen several miles deep. The atmosphere has partially collapsed, with much of the carbon dioxide and water vapor frozen out. What remains is a thin shell of nitrogen and oxygen, growing thinner each day. According to planetary scientists, within a year, Earth's atmosphere would be unrecognizable. Eventually, even oxygen and nitrogen would freeze, falling as snow and leaving the planet in a near vacuum. Earth would become like a comet, a frozen ball of ice and rock, surrounded by a thin haze of frozen gases. But in that first month, the survivors underground would be adapting to their new reality. Life in artificial environments, days and nights defined by clocks, not sunlight. Food grown under LED lights, water recycled endlessly. A closed-loop existence, cut off from the surface, from nature, from everything that once defined human life. The population would be small, maybe a few thousand people scattered across the globe in isolated bunkers. Communication between them would be possible, using radio or internet infrastructure that still functions, but travel would be impossible. The surface is too cold, too dangerous. These communities would face psychological challenges as profound as physical ones. Living underground, never seeing the sky, knowing the world above is dead. The mental strain would be immense. Depression, anxiety, and despair would be common, but humans adapt. Over time, new cultures would form. Children born in these bunkers would know no other life. The surface world would become a myth, a story told by elders. The sun would become a legend, a bright disk in the sky that their ancestors once knew. And Earth would continue drifting, silent, dark, frozen. A tomb carrying the last remnants of a species that once looked up at the stars and dreamed of reaching them. Take a breath. 1 month has passed. Most of life is gone. But deep below, in the warmth of Earth's core, the story continues. If this quiet journey has brought you even a small moment of peace, I'm deeply grateful you've spent it here with me. A gentle like or a soft tap on subscribe means more than you can imagine. It's what keeps me creating these cosmic lullabies for wandering minds like yours. Until next time, may the sun continue to shine on you, warm and constant, the one star we cannot afford to lose.